This conference will now be recorded.
Hey guys, welcome all. So we'll start the session now. So yesterday we have covered till we have seen map, we have seen flat map. Sorry, not flat map. We have seen about filter. Now we will start about distinct. So before starting today's session, anybody have any questions so far in the previous day session? Any questions? Let me know. I'll wait for a couple of minutes. I think there are no questions. I think we are good to move on. So I have already launched my PySpark shell. Now I'm going to start with distinct. So distinct is generally used if you wanted to avoid any duplicate. Suppose if we take this RDD and we have these elements, you can see that element 3 is repeating 2 times. So we can eliminate these duplicates by using distinct. So after using distinct, it will drop the duplicate elements. You will be left with only the unique elements. So let's do the hands-on. So create the RDD which holds the integer values and find only the unique values from it. So I'm going to create an RDD. Let's say int RDD equal to sc dot. You can pass on this parallels and then pass on your list here directly. 11, 22, 33. So you have this int RDD created. Right? And then you can actually look at the contents. So you can say int underscore RDD dot collect. So now the goal is to avoid the duplicates. How to remove the duplicates from this RDD? To remove the duplicates from this RDD, I'm going to use distinct. So let's say I would like to create an RDD called as unique RDD. I can just say int RDD dot distinct. So let's look at the contents of unique RDD now. Now you might see these warnings, ignore these warnings. Finally, you can see that there are only the unique elements here. And one important property of distinct is after listing, the number of elements must be less than or equal to your. Guys, can you hear me? Am I audible? Can someone confirm? Can you hear me?
Yes, Vamsi.
Am I audible? Can someone confirm? Okay, thank you.
Yes.
So after applying distinct, after applying distinct, the number of, uh, I think Sabina, it's better now, I believe, right? I'm audible, I think. So after applying distinct, the number of elements in your final RDD will be less than or equal to your initial RDD. To confirm that, what you could do is you could say int RDD dot count. So I'm getting the count of the elements from my initial RDD. It's having 6 elements. Now I'm going to look at the count of the elements in my unique RDD which I have created it by applying distinct. So again, ignore these warnings. So you can see it showing us 3, right? So these are the couple of properties of distinct. Once you apply distinct, all the elements should be unique. And the second property is number of elements must be less than or equal to your initial RDD. So let's talk about actions. So whatever we have seen till now, they are all called as transformations. All those transformations will create an RDD for you, right? So in fact, even if you go and check the type of unique RDD, that will be an RDD, right? You can see it's showing us pipeline RDD. Always remember, after applying transformation, you will always get an RDD. After applying an action, you'll always get a single number or a list of numbers. So whatever we have seen till now, they're all called as transformations. Now we have already seen plenty of actions. In fact, count is an action, which will get me the total number of elements in the RDD. In fact, collect is also an action, which will get me the entire data. But one important point which I would like to highlight with respect to collect is it is uh, actually you have to be a little careful when you call collect, because the reason is it will try to get the entire data to the driver's RAM. When you call collect, collect being an action, it's going to get the entire data to the driver's RAM or memory. If the driver's RAM is not sufficient enough, you might see out of memory issues because it will try to get the entire RDD to the driver's RAM. So you have to be a little careful when you call collect, because there are chances of your driver getting crashed. If the data that it is going to bring into the driver's RAM is not sufficient enough, your driver will crash with out of memory issues. So that's where we will try to avoid calling collect as much as possible. So instead of using collect, we'll use other actions such as take. Take will get you only the subset of the data, and we can also use first or take, not collect. Collect is not the preferred choice because it might throw the out of memory issues. Okay, now let's talk about one of the action called as reduce. So have a look here. I have this RDD with these 4 elements. Suppose I wanted to find out the sum of all these elements by using reduce. You can see 1 plus 2 will give me 3, and 3 plus 3 added you'll get 6, and 6 plus 4 is 10, right? And that element 10 will be returned. So let's do the hands-on for the same. Create an RDD, the elements 1 to 5, and find the sum of the numbers from 1 to 5 by using reduce. So let me first create an RDD with the elements from 1 to 5. Let's say int RDD equal to sc dot parallels, and then pass your elements. I'll pass the elements from 1 to 5. 1, 2, 3, 4, 5. And I would like to first check the contents. Let's say int RDD dot collect will get me the entire data. Now you can see that we have the data. Now what I would like to do is I basically wanted to find out the sum of the numbers by using reduce. So sum of the numbers is actually equal to int RDD dot reduce. Always remember lambda works on 2 elements at a time. So I'm going to have x comma y, and then say x plus y. Now once this is done, you should be able to see the sum of the numbers. Try to print some of the numbers. You can see it showing us 15. Even if you add manual also, you should be able to get the same output. So reduce is an action because Once you apply reduce, you will not get an RDD, you will get a single element or list of elements. So to confirm that, you can say type of sum of numbers. So this is an integer. Because reduce is an action, it will not return you an RDD as an output, it will return you an integer or list of numbers as an output. So now I wanted to go back to one of the important concepts called as flat map. So before talking about flat map, in map, what have we learned? So guys, this is very, very important again. In map, what have we learned? For every input element, there will be exactly one output element, right? For every input element, there will be exactly one output element. But whereas in case of flat map, for every input element, there could be more than one output element. There could be more than one output element. This is with respect to the flat map. But whereas coming to map, for every input element, there will be exactly one output element. Whereas coming to flat map, for every input element, there can be more than one output element also. To give you more clarity, let's say I have this RDD with 3 items or 3 elements in it. Now you can see that this red color border is representing flat map. Once you start applying flat map, you will see that for every input element, I can see multiple output elements getting generated, right? So you can see before applying flat map, I just had only 3 elements. After applying flat map, I can see totally 9 elements. Let's do one thing. Let's do the hands-on to understand it better. So create an RDD, find the word count using flat map. This is again very, very important interview question. I'll tell you how this question can be asked in the interviews. So this is again very famous interview question. So they may straight away ask you about the word count program in Spark. So they may say, write the word count program in Spark. Or they may ask you an indirect question. I have a file with some content and find the number of times each word is repeating or occurring. Right? So this is the question that you might get. Both are same. Again, very famous interview question. So now let us see how to basically tackle this. So first I will show the sample data. I'll go to my C drive data folder. I have a file called as sample. So you can see that this is the file. This is the file that I've got. Now my goal is to find out number of times each and every word is repeating. If you take the word hello is actually repeating totally 5 times. If you take world, the word world is repeating totally 4 times. Right? If you take fine, the word fine is repeating totally 3 times. So I have to get all that by using Spark RDDs. So first let's create an RDD out of this. I'll get this file path sample.txt and then I can create an RDD first. Let's say sample underscore RDD equal to sc.text file, and then in the double quotes you can give that path. So wherever you have slash, replace that with double slash. I have this RDD created. I can check the contents by saying sample underscore RDD dot collect, and I can see the content. You can also use for loop for line in sample RDD dot collect print line. So here line is nothing but a variable. It can be any name, and I can see the contents. So remember the goal. Our goal is to find out the number of times each and every word is repeating. Hence, what I should do is I should break each and every line to get all the individual words. So that is where I'm going to use flat map. So let's say flat map RDD equal to sample RDD dot flat map lambda function again. Take each and every line and then apply the split logic. So split it based on space as the delimiter or separator. So now I would like to see the contents from the flat map RDD. So after applying flat map, we are going to get individual words. Hence, I'm going to say for word in flat map RDD dot collect, then print all those words. So you can see that I'm getting all the individual words. But again, we are not done yet. We are breaking each and every line, getting individual words. Now to get the word count, we have to basically use something called as map transformation now. I'll tell you why we are going to use map function shortly, but let me go ahead and use map RDD equal to flat map RDD, basically the previously created RDD dot map lambda, take each and every word and then say word comma 1. So what I'm trying to do here, I'm taking each and every word and I'm trying to create a tuple out of this by using this round bracket or parenthesis. Let's see the output. I'm going to print the output now. Now you can see here I took each and every word. I've converted each and every word into the tuple form. It is also called as paired RDD because we have two elements, right? So that's why it is called as paired RDD if you have the elements in this tuple form. Now why do we need to have the data in this form? Because we are going to get the final word count RDD, WC RDD, word count RDD by applying reduce by key. That is map RDD dot reduce by key. So reduce by key is also a transformation and it will also work on two elements at a time similar to reduce. Lambda x comma y and then x plus y. But there is one condition before using reduce by key. The element should be in the form of this tuple form. It is also called as paired RDD. Only then reduce by key will work. Hence, we applied map before applying reduce by key to get all the elements in this tuple form or paired RDD form. Enter. Now you should have this final RDD called as word count RDD. You can try printing it. You might see these warnings, ignore these warnings for now, but have a look at the output. I can see that hello is repeating 5 times, world is repeating 4 times, fine is repeating 3 times, and so on. And that is what is expected, right? So in the interviews, they may ask you direct questions such as write the word count program in Spark, or they may ask you an indirect question saying, I have a file with some content, find out the number of times each and every word is repeating or occurring. So this is how you're going to solve it, right? And let me show you something interesting. So I will go ahead and open my browser. I will say localhost colon 4040. Interestingly, I can see Spark Web UI. So this is called a Spark Web UI, which is accessible by saying localhost colon port number is 4040. Now we are seeing this because the PySpark shell is up and running. If I stop this PySpark shell, you won't be able to access it. Let me say exit. I have exited from it. Now if I refresh my browser, it won't show up. It is gone. The point is very clear. You can access the Spark Web UI by saying localhost colon 4040. 4040 is the port number on which Spark Web UI runs by default. And the Spark Web UI is accessible only if the PySpark shell is up and running. If you are exiting from it, then you cannot access it. Right? So let's do one thing. Let's launch PySpark shell once again. So I'm launching PySpark shell once again. So sometimes it might get stuck. You have to hit enter on your keyboard. So I have the Spark shell launched now. Now, because I have launched the Spark shell, I should be able to access it as well. Guys, just to confirm, am I audible? Can someone confirm?
Yes, Vamsi.
Can you? Okay, Sabina, are you good? I don't know. These days I'm seeing some issues with my internet. Otherwise, it was really good. Okay, I think we're good. So now you can see immediately I'm able to access the Spark FBO on the port 4040, right? So sometimes in interviews they may ask you this question: Can you tell me the default port on which Spark FBO runs? So the Spark FBO is accessible on the port 4040, and for now it is accessible only if you have the Spark shell, PySpark shell up and running. And interestingly, I'm not seeing anything. You can see that there is a jobs tab. There is nothing. If I can click on stages tab, there is also nothing, right? There is nothing basically. Now let's do one thing. Let's try to write the same word count program once again. I will write it from the scratch again now. So I'm going to go ahead and then say sample RDD equal to sc dot text file. I'm going to recreate the entire program once again. I'm going to use backslash to create the sample RDD. Then I'm going to use flat map RDD equal to sample RDD dot flat map. Use lambda, take each and every line and then split it based on space as the delimiter or separator. Then I'm going to create map RDD because I wanted to apply reduce by key. Reduce by key works only if the elements are in the form of tuple form or paired RDD form. Hence, I'm applying map transformation here so that map takes each and every word and then converts it into the tuple form or the paired RDD form. Hence, I'm applying map transformation here. Take each and every word, convert it into the tuple form by using this round brackets or parentheses. And then once I have the data in this form, I'll have my final word count RDD, which can be obtained by using map RDD dot reduce by key. Reduce by key. Reduce by key always works only if the elements are in the form of key value pair, the paired RDD form basically. So that's where I'm going to mention x comma y and then x plus y, right? So I have done so much here. Let's go and see on the Spark API. I'm in Jobs tab. Refresh the browser. I'm not seeing anything. I'm in Stages tab. I'm not seeing anything again. Right? So why is it so? I'm not seeing anything even though I've done so much. I've applied so many transformations here, but I'm not seeing anything going on in the Spark API. Nothing in Stages tab, nothing in Jobs tab. Okay, so let's do one thing. Let's try to call an action. Action called as collect. So you might see these warnings, ignore these warnings, but I can see the output. You can see that hello is repeating 5 times, and then world is repeating 4 times, fine is repeating 3 times, and so on. So now we have called an action called as collect, right? Let's go to the Spark API, refresh the browser in the jobs tab. Immediately I can see an entry. Now why is it so? So this is because Spark follows something called as lazy evaluation. What is the meaning of lazy evaluation? All the transformations in Spark, all the transformations in Spark are lazy in nature. And what are some of the examples of transformation? Whatever we applied till now, they're all transformation. So text file is also a transformation. Flat map is also a transformation. Map is also a transformation. Reduce by key also is a transformation. And whereas all the actions are eager. or non-lazy in nature. So again, the examples could be collect. So collect is an action and it is eager or non-lazy in nature. If you observe carefully, before calling collect, I was calling only the transformations, text file, flat map, reduce by, all these are transformations. And transformations are lazy in nature. That is, until unless really required, they are not going to do anything. They are not going to get executed. Until unless you call an action called as collect. And immediately as soon as I called collect, I can see in the jobs tab there is one entry for the collect, right? So transformations are lazy in nature and collect or on actions are eager in nature. That is, until unless you call an action, nothing gets executed. That is why Spark follows lazy evaluation in Spark. And immediately you can see that as soon as I call an action, I can see one job in the jobs tab. So the point which I want to make here is number of jobs is equal to number of actions called. So how many actions are we calling here? We are calling only collect. So that's why you are seeing the number of jobs on the jobs tab is 1, because number of jobs is equal to number of actions called. We are calling only one action, which is nothing but collect. Right? Now, what about number of stages? Before talking about number of stages, I want to talk about types of transformations. There are two types of transformations in Spark called as narrow transformation and wide transformation. So what is narrow transformation? Narrow transformation is something where the data shuffling is not involved. But before talking about narrow and wide transformation, I want to talk about data shuffling. So data shuffling is nothing but data movement, data movement across the cluster, data movement across the cluster, or data movement across the worker machines in the cluster, data movement across the worker machines in the cluster, right? So, so narrow transformations are the transformations where the data shuffling is not involved. Data shuffling is not involved. Whereas wide transformations are the transformations where the data shuffling is involved. So what are some of the examples for the narrow transformation? Filter, map, flat map. So these are the examples for the narrow transformation. So what are the examples for the wide transformation? So reduce by key is an example for the wide transformation. Now why am I talking about narrow and wide transformations all of a sudden? Because there is a reason behind it. Number of stages is dependent on the number of wide transformations that you have. So number of stages is equal to number of wide transformations, plus 1. So how many wide transformations do we have in our code here? Only one, reduce by key. So because of reduce by key, you will see one stage. So 1 plus 1. Totally you will have 2 stages. Go to the stages tab here. You can see exactly 2 stages. Right? Also, you can see something called as DAG. So what you can do is you can go to the jobs tab, click on this link here, and by the way, you can see the stages also. You can see that there is a column called as stages. It's showing us 2 by 2, which means there are 2 stages and both are successful. And how many jobs we have? We have only one job. Click on this hyperlink in the collect here in the description tab. You can also see the stages here. So what have we learned? We have learned this job hierarchy, right? Job contains stages, and based on what the job has been broken into stages based on the wide transformations, right? And also we have learned that stages contains tasks. So we are clear with the number of jobs. How are you getting the number of jobs? Depends on the number of actions that you are calling. In this code, we have just only one action called as collect. Hence, you're seeing only one job on the jobs tab, right? If you can click on jobs tab, there is only one job. And number of stages is actually equal to the number of wire transformations that you have called plus one. How many wire transformations that you have in our code here? Only one, reduced by key. Hence, you can see 1 plus 1, 2. We will have one initial stage, hence I'm giving plus 1 here. And where can we see this? In the graph form. Click on this hyperlink here and expand this DAG visualization. You can see something called as DAG visualization. Expand this. You can see this. We have two stages, right? So whenever you call wide transformation such as reduce by key, it will create a new stage for you, right? If you can click on this, if you can place your mouse pointer here, you can see it is saying that reduce by key is something. It is actually creating a new stage for you, and you can see this uh, arrow that is going on is actually representing that this is creating a new stage for you. And I told that reduce by key is a wide transformation because data shuffling is involved. Sorry, there is a typo here. At line number 39, I fixed the typo. Data shuffling is involved in case of wide transformation. Example is reduce by key. Now, where can I see the shuffle operation? You can see a tab here on the right hand side. The first stage is doing shuffle right, 425 bytes, and the same data is written by the next stage, 425 bytes, shuffle read, right? Now, which transformation is calling this reduce back? You can say, you can place your mouse pointer here. You can see here on this dot, it is showing as reduce by key. And we also have an initial stage called as stage 0. As soon as you call a wide transformation called as reduce by key, immediately it is creating a new stage for you. Guys, clear so far? Any questions still now? Let me know if you have anything that is missing. I'll wait for 2 minutes here because today's session is very important, and I don't think any trainer will cover this because these are very important things, and these are very internal details, very important from the interview perspective as well. So we are clear with the number of jobs, and we are clear with the number of stages, right? Now, what about the number of tasks? Because that's the hierarchy, right? I told in the initial session of Spark, job has been broken into stages based on what? Based on the number of wire transformation, and stages have been further broken down into tasks, right? So how can we get the number of tasks? So number of tasks is actually number of tasks in a stage is actually equal to the number of partitions in the RDD. So how many partitions do you have in this RDD? Let's go and figure out. WC RDD dot get num partitions. How many partitions do you have? Only two partitions, right? Now if I can click on any of this stage, and by the way, you can see on the right hand side there is a column called as tasks. Each stage is containing two tasks. You can see 2 by 2. If you can click on any of this stage, you can see, if you can scroll down, you can see the tasks also at the bottom, right? There are two tasks. So number of tasks in a stage equal to number of partitions in the RDD equal to which is nothing but 2. Clear guys? Clear so far? And I told that transformations are lazy in nature. Now interestingly, as soon as I called an action called as collect, everything started executing. But where are we keeping track of all these operations? So we are keeping track of all these operations by using something called as lineage graph. So Spark Spark actually gets the fault tolerance capability. And by the way, Hadoop or HDFS gets the fault tolerance capability, get the fault tolerance capability by using replication factor, replication of the blocks, right? So how do we get the fault tolerance capability in Spark? By using lineage graph. So how can we see the lineage graph? So we can see the lineage graph by calling dot to debug string. So I'm going to call to debug string now, wcrdd dot to debug string. So this is the lineage graph that I was talking about. Copy this and then let me paste it here. This is the lineage graph that I was talking about. Spark keeps track of all the operation that it will have to perform, and then it will start applying all of them one as soon as you call an action called as collect. Until unless you call an action, nothing gets executed. Right? It is something similar to that. Let's say you have an exam, and most of the students will study just one day before the exam, right? And before one day, they have to cover the entire syllabus, right? They know what the syllabus is, but they won't study, but they will study only just before the exam, right? The same thing is happening here. Until unless you call an action, nothing gets executed. But Spark keeps track of all the operations that it will have to perform by using the lineage graph. You have to read this from bottom to top. You can see that we are using text file to create the RDD. Then we are applying all the other operations. Flat, map, reduce by key, and all those can be seen here, right? So, and also you might get another interview question. What is DAG? DAG stands for directed acyclic graph. So where can we see this DAG? We have already seen this DAG on the Spark Web UI. If you can go to Jobs tab, click on this hyperlink in the description column, and you can see the DAG. What is this DAG? You can see it shows a graph of stages executed for this job, right? You can expand this DAG. You can see the stages. Any questions till here, guys? As I'm telling, today's session is very, very important. Any questions till now? Now you are clear with each of the stages, right? Now when I say stages, so you are clear with job, stages, and tasks, how they are created, and why they are created with those numbers. We are clear so far. So one more interview question which I would like to highlight here is, what is the difference between reduce and reduce by key? What is the difference between reduce and then reduce by key? So reduce is an action, right? Reduce is an action, whereas reduce by key is a transformation, right? So what will reduce will return you? Reduce will return a single number as an output, right? So sorry for the interruption. So reduce is an action, right? Reduce is an action. What about reduce by key? Reduce by key is a transformation, right? And it will return you always an RDD. Reduce by key will return an RDD always. So this is also one of the interview question. What is the difference between reduce and then reduce by key? Right? So clear so far. Any questions? Anybody have any questions? Let me know. Again, very important session. If there are any questions, please feel free to ask. Okay, now I think we are good. I don't think there are any other question. Now what we'll try to do is we'll try to write this data. So we have this RDD available. To write this data to any location, I'm going to use an action called as save as text file. Save as text file is an action. I'm going to write the data into a given path by using save as text file. So let's do one thing. I'll go to my C drive data folder, C drive. data folder here. I would like to write my data here, right? So let's say wc underscore rdd dot save as text file. So in the double quotes, I'm going to give the path. So C drive data folder is the path, and within that, I wanted to create a folder with the name called as, let's say, word count rdd output November 2022. So this will go to C drive data folder. It will create a folder with this name. Enter. Now let's go to C drive data folder. So you can scroll to the bottom. You can see this folder wcrdd underscore output underscore November 2022. Go inside that and you can see the files. So you can look at the type column here. You can see type column is showing us CRC. We will ignore the CRC files. We will not worry about this. Apart from that, you can have one empty file called as underscore success. This is an empty file because look at the size. It's showing us 0 bytes, right? 0 KB. And apart from that, I have exactly two files. Now, why exactly two files? Because the number of partitions were two. So the number of files created in your output will be equal to the number of partitions that you have got. Because there are two partitions in this RDD, you are seeing exactly two output files. Two part files here. So let's open one of the file. I'm going to use any editor such as Notepad or Notepad++ to open the file. I'm trying to open the file so you can see the content, right? And this is what is expected. So whenever you try to write the data to a given destination, number of output files that you have here is actually equal to the number of number of partitions that you have got on the given RDD, right? And also remember, save as text file is also an action, right? Save as text file is also an action. You can see here, I can see one more job, which is actually coming because of the save as text file. Okay, so guys, just to summarize, two kinds of operations that we can do in Spark: transformations and actions. Always transformation will return an RDD, action will return a single number or list of numbers. And as I told, you can see always transformations will return a new RDD, whereas actions will return the values or results, right? Suppose if you had done 5 transformations on RDD, and to see the results, we have to apply an action such as count, take, or collect. And when we apply the transformations on a given RDD, it will create a new RDD. It won't change the existing RDD. And that's what we have seen in the previous session. RDDs are immutable in nature. That is, they are not modifiable. It won't change your original RDD. So these are the transformations that we have seen. To change your data row level, we have to use either flat map or map. To filter your data, you have to apply filter. To get the distinct values or unique values, you have to apply distinct. And reduce is an action which takes two arguments and return one value. And collect is an action which returns all the elements as an array or a list to the driver memory or driver RAM. Hence, it is you have to be a little careful when you call collect, otherwise you might see out of memory issues. And count is an action which will return the number of elements in RDD. First is also an action which will return the first element. Take is also an action which will return an array or list with first n elements. Based on previous session and today's session, I got some assignments for you, right? So what I would highly encourage is go through previous recording, practice everything. Go through today's recording, practice everything. Solve these assignments, right? So these are very important again. And I've got some interview questions also based on previous session and today's session. So please go through the recording, practice everything. Only then solve these assignments and interview questions. Only then you can understand it better. So, and in the previous session, previous day session folder, I have already uploaded the data, whatever you require. I'll just show that. So whatever data that I've been using, I have uploaded everything in the previous day folder. You can just go ahead and have a look. I'm just showing the same. So you can see retail DB folder here. If you go inside this, you'll find all these folders. So just download this. You should be able to follow the same whatever I'm talking in the session. Any questions before wrapping up today's session? And tomorrow we will see how to practice Spark online without installing any software. And good thing is you can start practicing within 5 minutes, and that too online, and that too for free for lifetime. Do you want to find out how? Then join tomorrow's session. Okay. So that's all for today. See you tomorrow then. I hope you enjoyed it. Bye bye.
Thank you.
Bye. See you.